Hello friends, this video on relations and functions part 28 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 27. Let's take some more example. We have to prove that if there is a function a to b and there is another function g that is b to c are onto, then g of f is also very similar to the previous question. Instead of 1 over it is 1 to a here. So the question says that there is a function f. So we have input as a, get b as output. There is a function f, and there is a function g. You get b as input, you get c as output. There is a function g. They are all onto. Onto means they are surjective. That is, there is no often element in these values. There is no often elements. Then we have to prove that GOF. GOF is what? A to C. Just explain. This becomes GOF. This is also on. Now we know that to prove any function, to prove general right, to prove any function, I'll not use f and g because it is there. So let's suppose that any function p, to prove any function px is onto, right, where it is from x to y. To prove any function p that is onto from x to y, we have to say that for every element, suppose this is capital Y and capital X, for every element small y that is member of this y, there exists small x that is member of big X. The function from x to y, then we say that for every element, because there is no orphan here, right? For every element that is here, there exists an element here. For in this case, for function f, we'll say for every element in B, there should be an element in A. For this, we have to say for every element in C, there has to be an element in B. Correct? Now, to prove, now what is given? First, let's say what is given. Given is f and g are onto. So, in f and g are onto, that means if f is onto for every element, let's suppose the element here are y1, y2, suppose. For every y that is member of B, right, there exists x that is member of A. Correct? If the element has x and y here, and here let's suppose y and z, for every element that is a member of B, there exists x that is member of A. Because since f is onto. Second one, for every z that is member of C, there exists y that is member of, since G is onto. So we have these two things given to us. Because f and g are onto, we can say that f is onto for every y that is member of B, there exists x that is member of A. And for this we can say for every z that is member of C, there exists y that is member of B. Now, to prove GOF x is onto, that is from A to C, we have to prove that if you see this becomes x, A is all x, and this is z, right? So we have to prove that for every z that is member of C, z that is member of C, there exists x that is member of. To prove GOF is onto, we have to prove that for every z that is member of C, there exists x that is member of A. If you can prove this, then it is onto. So let's see this. G of fx, you can write as nothing but G of fx. Correct. Now fx is nothing but y. That is G of y. Correct. So you see what I am trying to say, and G of y is nothing but z. So you take any element G of fx, fx is nothing but y, because for every fx there is a guy here, x. So I can say that fx is y, because for every y there is fx. So I can nicely say G of fx is y, and again G of y is z. Why? Because for every z there is a y here, because G is onto. Since f is onto, I could have written f of x equal to y. See, f of x is equal to y, I can write y, because for every y there is an x. For every y there is an x. So I can write f of x equal to y. Also I can write G of y is equal to z. Why? Because for every z there is a y, because G is onto. That's why fx I wrote as y, and the whole G of y I wrote as z. So I got G of fx is z. That means for every z there is an x, and that is what we were supposed to prove. So we are supposed to prove that for every z that is a member of C, because this function is from A to C. For every z that is a member of C, there exists x that is a member of A, and thus G of is also onto function. Let's take one more example. So we have function f and g such that the composite function is 101. So the question says g of f is 101, and we have to find that f and g are 101 or not. Right? This is what we have to find. So to start with, what we can do is we can create a hypothetical function. Let's suppose this is a function f. Let's say some values, let's suppose 1, 2, 3. Since this is 101, it will have some values here. Let's suppose here also it's 1, 2, 3. Since this is 101, it can have other values also, 4, 5. It can be onto. Thing is, it is just 101. This is my f function. And again, can I have a g function here? This is g function. That is also 101. No, that is not 101, but the whole function g of f is 101. So to make g of f 101, let me again write here 1, 2, 3, 4, 5, 6, 7 kind of thing. So 1 will point to 1, 2 will point to 2, 3 will point to 3. So this itself is a 101 function. If you see, this is f and this is g. So f of g will be something like, you give 1, 2, 3 as input, you get 1, 2, 3 as output also. But now if you see, there are some elements 4 and 5 which are off an element, so f is not 101. That is, f is not onto. It is 101 but not onto. So I can do anything with these elements. I can map this guy and this guy to same guy. Even if I map this guy 4 and 5 to 5, the whole function still remains 101. Why? Because we are bothered only about these sets which are linked. These sets are extra elements. You're not bothered. So if you see, f is 101 but g is not 101. Correct? Thus, we can prove that, or we can tell that just by giving this example, that if g of f is 101, f and g need not be 101. Correct? If g of f is 101, f and g need not be 101. This is just one example. This example we have got after a lot of thinking. Just remember this. If this question comes, we can just tell that, okay, this is f function and this is 101 but not on top. We have some extra elements. These extra elements can point to extra elements here. This will not impact the whole ecosystem here. This ecosystem will have 1 to 3 mapping to 1 to 3, which will still be 101. Even if you have, let's suppose 7 here and that all the points to 5, it does not impact this ecosystem, because GOF ecosystem is this much only. Correct? So if GOF is defined and it is 1, it does not mean that F. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.